indeterminacy, degree of kinematic indeterminacy. We have discussed how to calculate the degree of static indeterminacy and decay value, that is degrees of freedom for different kind of structures. We have seen some beautiful questions there. We have seen how to analyze stresses. We have seen the chapter analysis of stresses, and we have discussed important concepts of that chapter, that is analysis of stresses. So this part 1 video is available in our GATE YouTube channel. You can just go through it. If you have not watched it, watch that part 1 video as well. It will be beneficial for you. And if you are new to this YouTube channel, consider subscribing it for more videos like this. Okay, so before starting this session, GATE score booster session on structural analysis, that is part 2. Let me see how many of you are here. Please show your presence by paying a hi. Show your presence by putting a message in the comment box. Yes, I can see Pooja. Good morning. Good morning, Gujmu. And I have Krishna here. Good morning. Good morning. Yeah. I think without wasting much time, we can start our session, right? In this particular session, I'm planning to discuss the important concepts of the remaining topics of structural analysis. Is force method of structural analysis. We have displacement methods of structural analysis. We have influence line diagrams, important concepts of influence line diagrams, and we have arches and cables, right? Just like we have done in the previous session, I have selected some topics, some questions, and with those questions, I'm planning to cover as many important concepts as possible from this subject, structural analysis, so that it will be beneficial for you in the GATE exam. So yes, it's very good. So I think we can get started, and we are going to start this session of GATE score booster on structural analysis with this question. Just like I told you in the previous session, I am repeating it in this session also. When you see a question, this question was appeared in GATE exam actually, but it's an important concept. Okay, that's why I have taken this. So when you see a question, try to understand what is given in the question and try to understand what he is asking us to find. Very, very important step you have to do after seeing a question. So try to read this question and tell me if you can try to solve this question and tell me the answer. I have not given options there. I have a reason for that. Try to read the question properly and try to find the answer for this particular question. Okay, I'll give you a few seconds. Give you a few seconds to do it. Understand what is given in this particular question. Understand what he is asking us to find and think how we can find it. Okay, read the question properly and get the answers. Yes, Krishna is giving me the answer as PL cube divided by 12 EI. Okay, very good, very good. Let me see. Let me see. Yeah. Okay. So I'll read the question for you. Okay, I'll read the question for you. I'll read in that way in which you should read the question in the examination. So what is given in the question? That's my prime target. Understand. The planar structure RST shown in the figure is a roller supported at S and is supported at the end R. We are given with a planar structure here. It is having a hinge support at one end. It is having a roller support on the other end. The beam is the structure is RST. Okay, we're having a cantilever portion here, right? Remember, RS and ST have uniform flexural rigidity, which means it is having uniform cross section throughout the length. And S is a rigid joint. S here is also a rigid joint. This means it's a rigid jointed structure. Consider only bending deformation and neglect the effect of self-weight and axial stiffening. Means axial deformations, shear deformations, all these things are neglected. Only considering the bending deformations. It's actually the general assumption in the case of rigid jointed plane frames. So these are the things given in the question. What he is asking us to find. Question is further saying that when the structure is subjected to a concentrated horizontal load P at the end T, we are having a horizontal load here at the end T, the magnitude of rotation at the support R. So indirectly, we have to understand that due to the load, horizontal load applied at the end T, there will be some rotation. There will be some rotation in this member, and because of that, there will be slopes at this end and slope at this end. What is the slope at the end R? That's what we have to calculate. Now we have to think how we can calculate the slope at the end R. So we have different methods for finding slopes and rotation in the structure, slopes or deflection in various points in a structure. We have double integration method, we have Macaulay's method, we have strain energy principles, we have different methods like strain energy principles are also there. We can use even standard results for finding the answers. Whatever the method you use, it's actually up to your aptitude. You can use any of the available methods for finding the answer. But in a competitive exam, just like GATE exam, accuracy is important and time is also important. We have to get the correct answer as quick as possible, as fast as possible. So which method have you used here? You can see Vaishnavi has given me the answer, EL square divided by 12 VI. And Krishna is also has also given me the answer, EL square divided by 12 VI. I mean, which method have you used here? Have you used strain energy principles, Macaulay's theorem, double integration? Which method have you preferred? Get the answer here, to get the rotation at the joint R. Yes, some of you might have used consistent deformation, method of consistent deformation. Some of you might have used standard results. Some of you might have used strain energy principles. So it's actually your aptitude. Selection of a particular method for finding something, I mean, which is required. It is actually completely depending upon your aptitude. You have to select a proper method for the question given. Here in this question, I'm going to use the standard results. In the class, we have discussed standard results of slopes and deflections. We have discussed all these things in the subject strength of materials, or you have covered those things in the class itself, I mean college classes. And those slopes and deflections at various points in some structures like cantilever beams, simply supported beams, fixed beams, we are going to study them as a standard results, and we are going to use them, we are going to apply them here in structural analysis to make the things easier for us. Okay, so I'll show you the standard results which you have to remember. You have to keep all these results ready with you in your mind, because this is going to be helpful in the examination. Here I have taken, you can see these are the standard results of slopes and deflection for the cantilever beam. You can consider taking a screenshot here. Slopes and deflection for a cantilever beam for various loading conditions. You can see here it's a cantilever beam supported subjected to a point load at the end, at the free end. And what is the delta max and what is the theta value? Theta value means slope at the end. Theta value, slope at the free end, which is the maximum slope, will be equal to PL square divided by 2EI. Remember this equation as it is. And the maximum deflection will be equal to PL cube divided by 3A. Similarly, if the point load is eccentric, it's not at the end, it is somewhere on the beam, somewhere at a distance, let us say A from the end. What will be the slope at the free end? It is A square divided by 2EA, and the deflection is PA square by 6EA into 3L minus A. Actually, no need to remember this equation. We can remember it as it is. I mean, like this. Deflection delta max will be equal to PA cube divided by PEI plus slope, that is PA square divided by 2EI into remaining distance, that is B. This is basically the equation we have used. This is basically the concept we have used to calculate the delta max here. You can check, both are same. Okay, and we have cantilever beam subjected to UDL throughout. In this case, what is the slope at the free end? It is WL cube by 6EI. What is the deflection at the free end? That is WL cube L raised to 4 divided by 8EI. Again, we're having a cantilever beam. Loading condition here is, the loading given here is a moment, right? Moment, concentrated moment at the free end. If you are having a concentrated moment at the free end, what is the slope there? Maximum slope will be at the free end, and it will be equal to ML by EI, and the deflection will be equal to ML square divided by 2EI. You have to remember all these equations. Just keep it in your mind, because this is going to be, this table itself is going to give at least 1 mark in the GATE exam. I can assure you that. There will be in every year in GATE paper, there will be a question which can be solved by using this standard results. These equations are useful in strength of materials. Of course, it is useful. And this is useful, as I told you now, it is useful in structural analysis. And in some concepts of pre-stress concrete, which is a part of design of reinforced concrete structures. I'll be taking a question on that when we take GATE Corbosa session on RCC. In that portion also, especially change in length of pre-stress cable and all, there also these standard results are useful. I mean, we'll be discussing it in the next slide. Stops and deflection for simply supported beams. So remember these standard results. This is going to fetch you 1 or 2 marks in the GATE exam. Okay, you should know how to apply these results. So just take a screenshot of these things. Very, very important. PL square by 2EA, PL cube by 3A, PA square by 2EA, PA square A cube divided by 3A plus PA square divided by 2EA into B, WL cube by 6EA, W raised to 4 divided by 8EA, ML by EA and ML square by 2EA, slopes and deflections. Only these highlighted parts are important. Okay, no need to remember these results which are unnecessary, not required for us. I'm telling you things which are required for you. Okay, you can, if you want, you can remember this as well, but it's exactly same as that of this delta max value. Only the L value is, L value is changing. It is X here. That's only difference. Remember these equations. I hope you already remember these equations, right or not? I have, when I was discussing it in the class, I have told you this to remember this, right? Similarly, just like I have told you just now, the standard results of slopes and deflection of cantilever beam, we have to discuss the standard results of slopes and deflection in case of simply supported beams as well. So what are the standard results of slopes and deflection in simply supported beam? Here also, I will tell you the important equations you have to remember. You can take the screenshot of this or you can keep it in your mind. Both are fine. So here we are having a simply supported beam and we are having a central point load. This point load here is at center, okay, which means it is acting at a distance L by 2 from both the ends. So what is the maximum value of the slope and where it will be occurring? And what is the maximum value of the deflection and where it will be occurring? These are the points you have to remember. So theta 1 and theta 2 will be same. Why? Because it is loading is symmetrical here. Theta 1 and theta 2, the slope at the ends will be the maximum and the slope will be is equal to PL square by 16 EI. Delta max, maximum deflection will be at the center and this maximum deflection will be equal to PL cube divided by 48 EI. You have to remember these two results. And again, if the loading is actually a bit eccentric in nature, then the slopes and deflection is somewhat like this. I will not recommend you to remember this, which is not that much required. But if you're interested, you can go with the slope of slope at both the ends. But deflection and remembering equations of such equations are not required. Okay, not required, not recommended. Okay. Till now there is no question from there are no questions from this particular topic. And again, simply supported beam with UDL throughout, what is the maximum slope? It will be occurring at the supports or near the supports. The equation for finding the slopes or the value of slopes at the ends of a simply supported beam subjected to UDL is WL by 24A. Here the maximum deflection is 5 WL raised to 4 divided by 384A. Here also, again, one of the most important result which I need you to understand, which I need you to remember till the end of the GATE exam, maybe till the end of your lifetime. Here, simply supported beam subjected to a concentrated moment at one end. What is the slope at both the ends? If you are applying a moment here, you can see this is theta 1 and this is theta 2. Theta 1 is the slope at the far end and theta 2 is the slope at the near end. That means the end where the moment is applied. So theta 1, comparing theta 1 and theta 2, which one is maximum here? Theta 1 will be maximum or theta 2 will be maximum? Wherever we are applying the moment, at that end, theta will be maximum. So we are having theta 1 here, that will be equal to ml by 6EA. Theta, that is at the far end, rotation will be equal to ml by 6EA. Theta 2, which is near end of the, where the moment is applied, there the moment is, the rotation is ml divided by EI. No need to remember this, but remember this delta, that is the deflection at the center of the beam, will be equal to ml square divided by 16A. So remember all these results, which will be important for us, which is in fact important for us. And again, if you are interested, you can discuss about fixed beams subjected to the same loading conditions. Can you tell me what is the equation? What is the equation for finding the maximum deflection in a fixed beam subjected to a central point load? Just like this. I'm having a fixed beam somewhat like this, and I'm applied with a central point load like this. This is acting at a distance L by 2. What is the delta max value? Anyone? What is the delta max value? Exactly, it will be equal to PL cube divided by 192 EI. It's perfect. Exactly, yes. Just like Krishna said, this is 1/4 of that simply supported beam. With the same conditions. Same conditions means only the support conditions are changed. It became a simply supported beam. Length remained the same, EA remained the same, loading condition remained the same. In that case, it will be equal to 1/4 of the deflection of the simply supported beam. That is the deflection at the center. The maximum deflection in the fixed beam will be equal to 1/4 of the deflection of the simply supported beam. The same loading condition and all. And again, if I consider again, and I'm sure that you are going to give me the answer here. If I'm having a fixed beam like this and I'm changing the loading condition from point load to UDL just like this. This is the UDL I'm considering. Tell me what is the maximum deflection here? Delta max will be equal to, what is the maximum deflection? WL raised to 4 divided by 384 EI will be the maximum deflection here. This will be 1/5 of the simply supported beam with the same loading conditions. Correct or not? Yes, very good, Krishna. Krishna and Vaishnavi, very good. And these are the standard results you should remember. Coming back to your question, you have to remember all these things. I'm just repeating that. You have to remember all these results. Now, how I can use that standard results to find the answer here? The question here is to find the magnitude of the rotation at the support R, which means due to the loading condition here, one second. Due to the loading here, there will be some changes. So here I can redraw the beam somewhat like this. I can idealize the figure somewhat like this. This became a simply supported beam like this. This is a simply supported beam like this. What is the effect of this P load here on this beam? What is the effect of that P load on this beam? Tell me, can anyone tell me what is the effect of that P load? And what is the effect of that horizontal load acting at the point P? This is at a distance L/2 from the rigid joint S. Exactly, it will be creating a moment. Is it a clockwise moment or anti-clockwise moment? It is going to create a clockwise moment somewhat like this, and the magnitude of that is P into L/2. The magnitude of that is P into L/2. As we know, the length of the beam is L. How the beam will be rotating? The beam will be rotating somewhat like this. It is a clockwise rotation. This is a clockwise moment. The beam will be rotating in the clockwise manner. So the rotation here, that is, let us say, theta S will be in the clockwise direction. We are asked to calculate the theta R. Now you can see it is just like our standard results, right? I've just seen when a simply supported beam is subjected to a concentrated moment at one end, what is the slope at the far end? What is the slope at the far end? Just look at the standard results. Just we have remembered it. We have remembered it, and we are going to recall it from our memory. What is the slope at the far end? Slope at the far end is ML divided by 6 EI. Correct or not? Agree with me or not? Hello? Slope at the far end. Exactly. The slope at the far end is theta R will be is equal to ML divided by 6 EI. What is the M value here? Is PL/2. Length here is L divided by 6 EI. Answer will be equal to PL square divided by 12 EI. This is the rotation at the far end. What if I ask you the rotation at the end is? What if I ask you the rotation at the end is the rotation at the near end? What will be your answer? Is it ML by 6 EI or is it ML by 3 EI? Which equation we have to use? Exactly, we have to use ML divided by 3 EI. M here is PL/2, N here is L, and is 3 EI divided by L. Krishna is asking me a doubt. I'll come to that, Krishna. Let me finish it first. PL square divided by 6 EI. Can you tell me what is the difference between theta S and theta R? I'm telling you the possible questions. What is the value of theta S minus theta R? What is the value? It will also become PL square divided by 12 EI. Sometimes they will be asking you the ratio of theta R to theta S. That is also possible. Or not? This kind of questions are also possible. You can calculate it. You can calculate it. Sometimes they can ask you the deflection at the center. Tell me the deflection at the center. I'm just extending the question further. Okay. This question, we were asked to calculate theta R only, theta at the slope at the far end, that is R only. We are extending the question a bit. We have calculated the slope at the end S. Now we have seen the difference between the slopes, effective slope, let's say, and what is the ratio of the slope at the end R and R to S. And now I'm asking you the central deflection. What is the central deflection? Can you tell me the central deflection? The equation for finding the center deflection at the center is ML square divided by 16 EI. Just directly use it here. ml square divided by 16 EI will be the central deflection, not the maximum deflection, it is a central deflection. So this is PL by 2 will be the moment, L square divided by 16 EI. What is the answer here? PL cube divided by 32 EI will be the central deflection here in this. Okay. These are some extra informations. The deflection at the center, ratio of theta r to theta s, the difference between the slopes, and theta at far end, theta at the near end. This kind of questions are possible. So what I'm trying to say is remembering the standard results is actually very, very important. See, if you see this standard results you have used right now, this is ml square by 16 EA. Usually we calculate it by the available methods like double integration, Macaulay's method. All these things are used to calculate the delta at the center. But doing that in the GATE exam to find the delta max value, sorry, delta at the center, is it recommended? No, we cannot do that. Why? Because we'll be having maybe 1 minute or 2 minutes for a question, right? So we cannot find, you cannot do such kind of activities in the examination, which will not be which will be taking first time, right? So remembering these standard results are always recommended. You have to keep it in your mind. Okay. So Krishna is asking me, sir, for slope, if they have not mentioned the magnitude, for slope, if they have not mentioned the magnitude, which we have to type the answer with sign, right? I'm not getting you, Krishna. They have not mentioned the magnitude. What we are asked to calculate, is it the theta or is it something else? They're not, no, if they're not mentioning that magnitude, you can put the answer there. That's it. You need not to go for the sign and all. Okay, if they're mentioning the magnitude, then you can think about it, clockwise or anti-clockwise. Okay, don't worry about such things. This is question 2 of this session. It's a very, very simple question. I know you are going to give me the answer within seconds, but the concept which is important, not the question. Okay, I want you to understand the concept. Stress we have discussed yesterday in the previous session, but the question is somewhat different. I'll read the question for you. What is the strain energy stored in the member AB of the truss shown in the figure below? We are having a member AB here, and we are asked to calculate the strain energy stored in the member. First of all, we should know the equation. We should know how to calculate the strain energy stored in a truss member. As I told you, as we know, in a truss member, what is the member force? Is it bending moment, or is it shear force, or is it axial force? What is the member force if you see a truss member? If you see a member of a hinge on a plane frame, what is the possible member forces? Yes, member forces will be due to axial forces. Sorry, member forces will be axial in nature. Due to these axial forces, there will be some axial deformations. If there is a tensile force, there will be extension. There will be axial extension in this member, and if the load is compressive in nature, there will be contraction in the member. See, what I'm trying to say is, when the member is undergoing some deformation, it can be bending deformation or it can be axial deformation, whatever it is. When the member undergoes some deformation, some kind of energy will be stored inside that body while undergoing that deformation. That is called strain energy. So what is the strain energy stored in a member, in an axial member, while undergoing axial deformation? That is actually basically the question which we have seen right now. How to calculate it? Remembering it is important. I'm going to denote the letter here. I'm going to denote the strain energy with the letter U. U represents the strain energy stored in a member while undergoing axial deformation. I want you people to give me the equation for this. I have, yes, whoever is present here, give me the answer. Give me the equation for finding the strain energy stored due to axial deformation. What is the equation? Let's finish it quickly. We know the equation, right? Yes, P square L divided by 2AE will be the strain energy stored in a particular member while undergoing axial deformation. I can say strain energy stored in a particular member in a truss or in a hinge on a plane frame will be equal to what? Will be equal to P square L divided by 2AE. Sorry, P square L divided by 2AE. We know the notations, right? What is P? P is the member force in that particular member. What is L? Length of that member. What is AE? Axial rigidity of that member. So here in this particular question, if you come back to this question, the strain energy stored in this member AB, let us say I'm going to call it as UAB. I'm going to call this UAB, where UAB represents the the strain energy stored in the member AB. You know the equation will be AB, that is force in member AB, square L divided by 2AE. This is for the member AB, right? Right. This is the equation for finding the strain energy stored in the member AB, right? Then what we have to do, we have to first calculate the force in member AB. Yesterday we have discussed, in the previous session we have discussed how to calculate the force in various members in a truss. We have to first apply the concept of zero force members to make the things easier for us. If you think, or if you talk about the concepts of zero force members, you can easily find that force in member AB is zero. Why it is zero? Apply the concept of zero force members. Three members are meeting at a particular joint. There is no external force or external reaction at that joint. Two of them are collinear, then the third non-collinear member will be a zero force member. You have seen it, how we are getting it in the previous session, right? Yeah, in the part one of this gates for both sessions. So if it is zero, strain energy will also be zero. That's the meaning of it. That's it. And finding the strain energy, finding the zero force members, finding the force in a truss member, it's actually very, very important in GATE exam. And if you are getting a question, consider yourself lucky. Why? Because chances of getting the answer, I mean, chance of getting the question correct is very, very high. Things are very simple, not difficult. No difficult concepts are involved in such kind of questions. Okay. So what if I ask you to calculate the total strain energy stored in the truss? What is the procedure? What we have to do? Here we are asked to calculate the strain energy stored in the member AB. What if I ask you what is the total strain energy stored in the truss? Also very simple. Suppose if I am taking a truss here. Suppose I'm taking a truss here. This is a truss, a very, very simple or basic truss. One end is hinged, other end is a roller. And suppose I have a, let us say, I have a loading here, okay? Let us consider that loading in the vertical direction. This is a load acting here. I'm going to call it as W. It is also there. And we know the length of the member. I'm going to consider the length of each member is L. And I'm going to name the truss. This is A, this is B, and this is C. Of course, due to this loading here, there will be some force in this member. I'm going to call that force as PAB. And of course, here there will be force in this member, in the remaining members as well. I'm going to consider the force in different members like this, like this. This is PAC and this is PBC, right? What is the total strain energy? Total strain energy will be equal to strain energy stored in the member AB, strain energy stored in the member BC, and strain energy stored in the member AC. This kind of question is also possible. It's very good, Krishna. We have to consider the equation here is for a total strain energy is equal to total strain energy will be equal to, it will be the summation of strain energy stored in various members. That will be equal to P square L divided by A. Remembering this is also important. Total strain energy in the entire truss will be equal to, what is the answer? The equation is sigma P square L divided by 2A. What's the meaning of it? Summation of the strain energy stored in various members. That's the meaning of it. Okay? This is the equations for finding the strain energy. I will ask you this. What is the significance? How it is going to help us in analyzing a structure? That's what our point, or that's what the thing in which we are interested in, right? How this is going to help us? Strain energy. Anyone? What is the significance of this strain energy? Anyone? Have you heard of the term? I think you are aware of the term called, aware of this theorem called Castigliano's theorem, right? What is this? What is Castigliano? Yes, exactly. Try saying that to find the deflection at various points on a load in that direction, to find the displacement of truss joints. Very good, Kasturidas. Abhi is also saying that maximum strain energy stored. Yes, that's also correct. It's why we are calculating strain energy, or how it is going to help us in analyzing the structure. The subject is structural analysis. We are studying strain energy, which means it is somewhat somehow useful for us to analyze a structure. Why we are analyzing a structure? In order to find the values, I mean maximum values of reaction, shear force, axial force, etc. And we are interested in calculating the slopes and deflection at various points in structure also. So Castigliano's theorem. What is Castigliano's theorem? If U is the total strain energy, I'm not going to write the theorem there. Understand what is the meaning of it. If U is the total strain energy stored in a truss, and if I take the partial derivative of the total strain energy with respect to that load, suppose here the load is W, here the load is W, and if U is the total strain energy stored here, and if I take the partial derivative of the total strain energy with respect to the load given, then I will be getting the displacement at that particular joint. where the loading is applied in the direction in which I applied the load. Getting my point? Castigliano's theorem. What is the meaning of Castigliano's theorem, or what he is saying in Castigliano's theorem? If you take the partial derivative of total strain energy with respect to a load acting at a particular point, that partial derivative will be giving you the displacement at that particular point of application of the load in the direction of the load given. Here, if I have taken that partial derivative with respect to W, this is W. W is acting at the point B, which means this will be giving you the delta value at the point B. As the W is acting in the vertical direction, it will be giving you the vertical displacement of the joint B, vertical displacement of the joint B. That's the meaning of it. So this is how strain energy is going to be helpful for us in analysis of stresses. There is a drawback. What is the drawback? Can you tell me what's the problem here? We will not be able to calculate the horizontal displacement if it is required by using Castigliano's theorem. Why? Because Castigliano's theorem is going to give you the displacement only at the point of application of the load in the direction of the load. If the load is vertical, you will be able to calculate only the vertical displacement, not the horizontal displacement. What will happen if I need to calculate the horizontal displacement? In this question, if I am asked to calculate the horizontal displacement, what you will do? Which method you will be preferring? Which method you will be preferring if you are asked to calculate the horizontal displacement? Anyone? Unit load method. Perfect answer. I told you in the class, whenever you are given with a truss and you are asked to calculate the displacement, whether it is vertical or horizontal, consider always, I mean, most of the times, using Maxwell's theorem or unit load method to get the answer. Here is a question for you. Read the question and try to get me the answer. I will also discuss. Follow the procedure. Try to understand what is given in the question and try to understand what he is asking us to find, and try to understand, to think how we can find it. So this is actually member U1 L2. Okay, not L1, it is L2. U1 L2. I'm interested in this member. Think about this. In the previous session, that is part 1 of Get Scoreboard session on structural analysis, I've discussed how to calculate various member forces. You can apply those concepts also here, that concept also here. Think about it, how to calculate the vertical deflection or vertical displacement at the joint L3. Go for it, please. Go for it, please. Yes. Which method I'll be using here? Which method I'll be using here? Vaishnavi will come to that, okay? We'll be discussing it. Which method I'll be using here for finding the vertical displacement? Exactly, we'll be using unit load method. Yes, try to think about it. Yeah. People can try this, but please interact with me, okay? If the member U1 L2, this is our member U1 L2, of the truss shown below is fabricated 15 mm short. Okay, this member is fabricated 15 mm short. The member length of the member is given, right? Suppose the length of this member is 5√2 or something like this. This is not exactly 5√2. The length of this member is 15 mm lesser than 5√2. That's the meaning of it. That means there is a lack of width in this member. So what we are asked to calculate? We are asked to calculate, determine the vertical deflection at L3. We have to report the answer in mm, round off to 2 decimal places. There is our joint. This is L3, and we are asked to calculate the vertical displacement at this point L3, at this joint L3. And this vertical displacement is actually due to this lack of it in this member. This member is 15 mm short. There is no external load acting in this member. There is no temperature change. But there is a fabrication error in this member U1 L2, and due to that fabrication error, we are assuming that there is a possible displacement of in this joint L3 in the vertical direction. We are interested in calculating the vertical displacement of that joint L3 due to this lack of it or due to this fabrication error in the member U1 L2. So when you see this question, you see such kind of questions where you are asked to calculate the vertical or horizontal displacement of trusses, there are around 3 cases. As I told you, we will be using Maxwell's method or we will be using unit load method. Both are same only. To find the horizontal or vertical displacements at various points in a truss. we have to consider different loading conditions, different conditions for finding the displacement. If that displacement, if they're asking us to calculate the displacement of a first joint due to external loading, what is the meaning of it? I'll tell you this. I'm taking a simple example. Try to understand for your understanding only, for making the things easier for you. Suppose there is a load acting here. This point is L. Okay. This is A, this is B, and this is somewhat C. Okay. I'm interested in calculating the horizontal displacement of the joint C. I'm interested in calculating the horizontal displacement of the joint C. This is what I am interested in. Okay. I'm interested in calculating the horizontal displacement of the joint C. How we can calculate this? Of course, can I use Castigliano's theorem here? Will I be able to use Castigliano's theorem? Will I be able to use Castigliano's theorem? No, I cannot use it. Why? Because if I use Castigliano's theorem, I will be getting the vertical displacement at the joint B, not the horizontal displacement of the joint C. The point. I have to use unit load method. As per unit load method, the equation for finding the horizontal displacement at C will be equal to summation of E A L divided by A. What is this? I will tell you this within a while. What is PAL divided by A? What is the meaning of each and every term here? P here. What is the value of P here? P here is actually the member forces or forcing these members due to the load applied here. The load applied here is P. Due to this, what is the member forces? That is the meaning of P. We'll be having some force here in this member AB. We'll be having some force here in this member BC. We'll be having some force in this member AC. That is what is the meaning of P value. That is what is the value of P. I think it's clear, right? Now coming to the second term, what is K? What is the K value? What is K value? What is K value? Anyone? In unit load method, as I am interested in the horizontal displacement at the point C, what we basically do is we will be applying a unit load at the point where we need the displacement. First point, we need the displacement at the point C, so that I'm going to apply one unit load here. Magnitude of that load is 1. And see, I can apply the load in the vertical direction. I can apply the load in the horizontal direction as well. But here I'll be applying the unit load in the horizontal direction. Why I am applying in the horizontal direction? Why? Because we have to apply the unit load in such a way that we have to apply that unit load in the direction in which I need the displacement. If I need the horizontal displacement here, I will be applying the unit load in the horizontal direction. As I need the horizontal displacement at the point C, I will be applying the unit load in the horizontal direction at the point C. And of course, we have to remove the external load as well. Now, the force in various members, calculate them. This will give you the K values, KAB, KBC, and KAC. Use it here. We know the length of each member. We know the axial residue of each member. So take the summation of them. You'll be getting the horizontal displacement of the joint C. This is the procedure for calculating the horizontal displacement of a joint when it is subjected to a vertical load. Is it clear, everyone? I think this equation is very much familiar to you, right? There are many number of questions from this single concept in GATE exam. You can see the previous question paper. Is this concept clear to everyone? If there is a doubt or something like that, you can simply ask me. I think this equation is familiar to you, and you know how to deal with this equation, right? And this is external loading gauge. It means there are the deflections or the displacements at various joints due to external loading. Some other possibilities are also there. Apart from this external loading, suppose if this member is subjected to a temperature change, there is a 30 degrees Celsius temperature change during the fabrication, during the construction of this truss. Suppose the initial temperature was around 15 degrees Celsius. Now temperature has become 45 degrees Celsius, which means there is a temperature change. Due to the temperature change, there can be some displacements at various joints. Suppose I'm expecting that there is a horizontal displacement at the point B. How to calculate the horizontal displacement there? Again, I will be using the unit load method. Equation for finding the horizontal displacement at the point, or equation for finding the delta value, I'm going to consider as delta value. Equation for finding the delta value will be equal to, in case of temperature, in case of displacement due to temperature change, equation here is summation of, one second, let me write it properly. Summation of K L alpha delta T. A L alpha delta T. Kasturidas is asking me a doubt. I'll come to that, Kasturi. I'll be discussing it. No, don't worry. Don't worry about that. I will be discussing it. So this is the summation of sigma K L alpha delta T. Use this equation, get the answer. The notations remain the same. So the symbols remain the same. K value. What is the K value? If I need the horizontal displacement here, I need to first apply a horizontal unit load here at the point B. Calculate the member forces KAB, KBC, and KAC and apply it here. Length of each member, alpha, coefficient of thermal expansion of the member, material, delta T is the temperature change. Okay. Similarly, what is the equation for finding the displacement due to lack of it? Equation here is sigma K into delta dash. What is delta dash? What is delta dash? Delta dash is actually lack of fit in various members. Suppose there is a member, this is the member here, okay? This is the member I am considering, and I am telling that this member is 10 mm shorter. I am considering that this member is 5 mm longer. 10 mm shorter means I am considering it as negative plus 5 mm shorter. This is how we represent it. The question is, what is the horizontal displacement of the joint C? How you will be doing it? Apply one unit load at the point C in the horizontal direction and get the answer here. A value, we know it is the force in various members due to the unit load applied at the point where we need the displacement. That is the meaning of K value. What is delta dash? Delta dash means the lack of it in various members if it is present in the structure. Now coming to Kasturi's doubt, what are the sign conventions? Very good. If the for external loading condition, P value will be taken as positive, and sometimes we have to consider as negative as well. P value will be taken positive when we will be considering P value as positive. Anyone? I know you need you are aware of these things, right? Yes. Exactly. If the nature of force there is tensile, I'll be considering it as positive. And if the nature of force there is compressive in nature, I have to consider it as negative. Same thing is applicable in case of K value also. Same thing is applicable in case of K value also. If it is tensile, I will be taking it as positive. If it is compressive, I will be taking it as negative. And coming to this equation, delta T value will be considered as positive and negative depending upon the change in temperature. If the temperature is increasing, suppose if the temperature has increased by 30 degrees Celsius, I have to consider that increase in temperature as positive. If there is a decrease in temperature, suppose the temperature has decreased by 30 degrees Celsius, in that case, I have to consider delta T as minus 30. Understand this, Kasturi Das? Getting this, Kasturi? Perfect. Again, coming to this point, delta dash, when I'll be considering it as positive and when I'll be considering it as negative. Delta dash value, that is lack of it values, has to be taken as positive and negative based on the fabrication error. I'll be considering it as positive if there is if the member, if there is an increase in the member. If the member is shortening, then it has to be taken as negative. If the member is shortened, if the member is shorter than the length of the member required, in that case, I'll be taking it as negative. If the member is longer than that is required, I'll be taking it as positive. That's it. Here, these are the sign convention. Here also, I will be considering the K value as positive if it is tension. I'll be considering it as negative if it is compressive. Got it? This is the concept I'll be using. This is the possibility. This is what we'll be using to calculate. This is the concept which we have to use to calculate the displacement at various joints in truss. When you are getting a question to calculate the horizontal or vertical displacement of truss joints, you simply use Maxwell's method to get the answer. Coming back to our question. Here we are asked to calculate the vertical displacement at the joint L3. This is joint L3. This is our joint L3, and we are asked to calculate the vertical displacement. And of course, it is saying that U1, L2, there is a fabrication error of 15 mm. If there is a fabrication error of 50 mm, and it is also saying that the member U1, L2 is shortened by 15 mm, which means I have to consider it as positive or negative. I have to consider it as negative, right? And what we have to do here, we have understood this. If there is a vertical displacement at this joint L3, that vertical displacement will be due to this fabrication error. I'm going to apply one unit load at this point L3 to find the horizontal vertical displacement at the point L3 due to this fabrication error. Now coming to what is the fabrication error in this member? I'm going to call it as delta U1, U2. What is the fabrication error in this member? Tell me the fabrication error. Exactly, it is 0. Why it is not mentioned, right? It is not mentioned there. Here also, it will be 0. Delta dash represent the fabrication error of the member L1, U1. Let us say U1, L1. Here also it will be 0. Here also I'm going to call it as 0. Here also it is 0. In all other members, the fabrication error is 0. Correct only? Yeah. So here in this member only, that is member U1, L2, the fabrication error is minus 15 mm. Remember this. Very, very important. I will tell you a shortcut here. Now, what you have to do? The equation here, which I have to use here is delta vertical displacement of the joint L3 will be equal to what is the equation? Summation of K into delta dash. What is K value? What is K value? K value is the force in various members due to this unit load applied. Correct? First of all, let us calculate it. But before that, do I need or do I have to calculate the member force in all the members? Tell me this. Do I have to calculate the force in this member? Do I have to calculate the force in this member? Do I have to calculate force in all the members? Tell me please. No, we don't have to calculate. So look at the equation. It is K into delta, which means, for example, K into U1 L2 into delta U1 L2, K into L2 L3 into delta dash L2 L3, which means we are multiplying the K value with the lack of it in various members. Only member U1 L2 is having lack of it, which means we need to calculate the K value of the member U1 L2. No other members are required, right? U1 L2. Why? Because only one member is having lack of it. Very good, yeah. Kasturi and Kushbu, Vaishnavi, very good. Right. So now we are interested in calculating K U1 L2, which means I need to calculate the force in this member. How I can calculate the force in that member? Which method I am going to prefer? Which method am I going to prefer? I'm going to prefer method of sections. I'm going to prefer method of sections to make the things easier for us, to make the things a bit quicker. This is the force in this member. I have applied a unit load here. This is the unit load. Suppose this is the force here, KU1 L2. For finding the force in this member, we know force in all these members will be released. I have three equilibrium equations. First one is sigma Fx is equal to 0, sigma Fy is equal to 0, and sigma M is equal to 0, as it is a couplant or non-couplant force system. Which equation will I be using to calculate the force in this member? So I think I have changed the question. This is not U1 L1, this is U1 L2. Okay, this is U1 L2. U1 L1 will not be having any influence on this member. Why? Because it is not having a lack of it. Only this member is having a lack of it. That's why I have changed it. Okay. So if I'm which equation will be useful for us to calculate the KU1 L2 value? Which equation? Sigma Fx cannot be used. Why? Because we will be having two more unknowns. Sigma Fy value, yes, we can use it. Why? Because only one unknown will be there. Okay, let us use it. I'm going to take this angle as theta. KU1 L2, KU1 L2. Yes, very good. Sine theta. I'll calculate theta. It is in the upward direction. I'm taking it as positive. But I need the reaction here. RL2. I need the reaction here. So let us calculate the reaction first. How to calculate the reaction? Consider the moment about L1 is equal to 0. And we know that 1 into 8 is in the clockwise direction. I'm going to take it as positive. Minus RL2 into 4 is equal to 0. Which means RL2 is equal to 2 units. Correct or not? RL2 is equal to 2 units. This is 2 units. If you this distance here is 4 meter, this distance will be equal to 2 meter. Theta value, I think it will come out to be 63.43, something like that. You can just confirm this answer. Right? What is the angle between these two members? I think it will come out to be 63.43 degrees. Okay, you can confirm this answer. I'll write it after this. Just confirm this once. And this is the upward direction. Plus 2 minus 1 will be equal to 0. This is how you will be getting when we use method of sections here, right? Yes, very good. Thanks for that. Yes, thanks for confirming this. 63.43. Now we know we can calculate KU1 L2, which will be equal to minus 1 divided by sine 63.43. Give me the answer here. What is the K1 U2 value? KU1 L2 value. What is the answer here? K1 L2 value. I need your answers. I think it will be around 1.11 something, right? I think it is around 1.118 mm. You can confirm this, not mm. It is in unit load, right? Yeah. What is the answer? I'm expecting your answers. It is coming out to be minus 1.118. Correct or not? Yes, thanks for confirming this. I need your responses. This is the value. And tell me why it is negative. Tell me why it is negative. It's negative, exactly. It is negative. Why? Because the assumption is wrong. The assumed direction was tensile. I got a negative answer, which means it is compressive in nature. We know the delta value here, right? Now we have the values. We have calculated KU1 L1, Q1 L2, and we know the delta dash values. Now we are going to apply it in the equation to calculate the vertical displacement of point L3. How to do it? This is minus 1.118. Why I am putting it as minus? Why I am using a negative value here? Why? Because assumption. Why? Because in the equation we know what we have to do. If it is tensile in nature, we will be taking it as positive. If it is compressive in nature, we will be taking it as negative. Here the answer is compressive. That's why I'm taking it as negative into 15 mm. Is it correct? No, it is not correct. Why? Because if the member is shortened by 15 mm, which means the length of the member is getting decreased. In that case, I have to consider it as negative. This will be the equation. I think it will come out to be 16.77 mm, something like this. You have to confirm this. You are getting a positive answer here. Again, there is a difference. If you are getting a positive value, what's the meaning of this? Can you tell me what is the meaning of this? If you are getting a positive value there, if you are getting a positive value, what's the meaning of it? Which means the assumption we have considered here in this unit load is correct. Which means the deflection will also be in the direction of the unit load considered. We were interested in calculating the vertical displacement. If we calculate the vertical displacement, I got a positive value. I have considered the unit load in the downward direction. The meaning of that is assumption is correct. Assumption was in the downward direction. The displacement will also be in the downward direction. Clear? Perfect answer. Perfect answer. Right. So this is how we will be calculating the displacement at various joints in a truss. Clear? Any doubts? Any doubts? Any doubts? For example, I'm considering a different scenario. There is a lack of width of 15 mm in this member. And along with that, suppose there is a load, there is a vertical load is also acting here. Suppose it is 75 kilonewton. And I'm asking you to calculate the vertical displacement of L3. How to calculate it? How to calculate it? Anyone? How to calculate it? Very good. First of all, we need to consider, if I am considering the effect of lack of width and external load together, the equation will become sigma pkl divided by AE plus sigma A into delta dash. This will be the equation. I have to consider the effect of the 75 kilonewton first, find the pkl by AE value, and after that I have to consider the effect of lack of width and get the displacement due to that and add them. You'll be getting the answer. Got the point? Got the point? And suppose there is a temperature increase of 30 degrees Celsius in this member. What will be doing? We have to add that as well in the equation. Sigma L alpha delta T. Always be careful about these values. P value is positive when it is tensile and negative when it is compressive. Same is applicable for K value. And delta dash, if the member is, length is increasing, positive, length is decreasing, negative. Delta, if it is increasing positive, if it is decreasing negative. And ultimately, if you are getting a delta L3 value as positive, applied unit load is in the correct direction, assumption is correct. If it was applied, if it was assumed the downward direction, the deflection will also be in the downward direction. If you assume the unit load in the upward direction and you got a positive value, meaning of that is unit load assumption, no, it was in the upward direction, right? The displacement will also be in the upward direction. You assume the unit load in the upward direction, but you got a negative value. What's the meaning of it? Displacement will be in the downward direction. Got the point? This is how we'll be calculating it. So forget about this 30 degrees Celsius increment, and I recommend you calculate this. I think, I'm not sure about this. Suppose if you are getting the value as 5.3 mm, you can just confirm it. Okay, you can just calculate it later. And we have already calculated this. This is around 6.77 something. So you can tell me the answer here. So it will be coming out to be 22 mm, right? Almost 22 mm. A value will be, you can assume it. You can assume it. You can assume it. Just assume the value. I'm assuming that I got the value as 5.32. Assuming that I got the value as 5.32. See, I will tell you one more thing here. In order to find this pKl by A value, it's always better to consider a table like this. It's always better to consider a table like this, where you will be considering various members like U1, L1, U2, L2, U3, L3, somewhat like this, and write the length of the member here, and write the force in various members, P, U1, L1, something like this. Find the K value and put it here. Find the length will also be given there. Axial rigidity, write the axial rigidity, and calculate the pKl value, and calculate the pKl by AE value. And in these cases, you can calculate the K delta dash value, and ultimately you'll be getting the values for each members, right? You'll be getting the values for each members, and ultimately you'll be taking the summation of pKl by AE here, and this is a summation of this column, right? This is summation of K into delta dash. Ultimately, take the summation of these two to get the answer. You'll be getting the answer as 22 mm. So using a table will be helping you a lot in saving time in GATE exam. Okay, try to use this table to make the things easier for us. So that's asking me, sir, there is no need of using unit load then because there is a load. No, it's not like that, Kasturidas. First of all, if I'm considering the effect of this lack of it only, I should not consider this unit load. I should not consider that external load. We'll be proceeding like this, and we'll be getting the value of 16.77. After that, forget about the effect of this lack of it and apply the unit load here. Apply the 75 kilonewton load here. Find the p values. Remove the external load and apply a unit load here. Find the k values here. And length of the member is known to us. AE value will also be given in the question, and get the pKl by AE value. Here, Kasturi. Suridas. Yep. Yeah. So this is how we will be proceeding. Will be, I am interested in telling you a few more concepts here. Two more concepts. Suppose I have a truss here. Let me draw a truss here. Let me draw a truss here. Give me a second. Give me a second. One more second. Yeah. So this is the truss given. Okay. This is the truss given. And there is a member AB. This is member AB. Why I'm asking you the question, what is the rotation? What is the rotation of the member AB in radians? That is what we have to find now. What you will do? We know it's a truss, right? We know it's a pin jointed plane frame or it is a truss. We know it is a truss. How to calculate the rotation of this member? What you will do? That's my question. Which method will you be using here? Which method will you be using here? It can be, this rotation can be of maybe of any reason. Let's say it be due to lack of weight, let it be due to temperature change, or let it be due to external loading. Whatever be the reason behind it, I'm interested in the concept of finding the rotation of a member. Okay, apply a unit moment. Okay, very good. See whether it is correct or not. Any other ideas how to calculate the rotation of the member AB? So, what do you think, Kasturi? Will you be applying a unit moment, unit couple, something like this? Which is not, which is not allowed in unit load method. In unit load method, instead of applying a moment like this, we will be applying a unit couple like this. We will be applying unit loads in this way. Okay, this is a unit load, but it should not be the unit load. It must be divided with the length of the member, LAB, and it also length of the member, LAB. This is the length of the member here is AB. Now you can see this is the member, right? If I am applying a unit load here, I am applying a unit load here, which means effectively you are applying a moment there of magnitude 1 LAB into LAB, which means 1 your moment there, right? So after that, calculate the K value in every member and ultimately using the equation PKL by AE or K into delta dash or K into L alpha delta T, you will be getting the rotation of that member in the variance. Clear? Is that clear, everyone? This is how we will be proceeding to calculate the rotation of the members. The point, rotation of members. Tell me, it is clear or not? I think it's clear, right? I think this concept is clear. We have seen the previous year gate paper. There is one more concept. Let me draw a truss here. Let me draw a truss here. Give me one more second. There's a truss. There is a truss somewhat like this. This is the truss we have. And what we are asked to calculate? We are asked to calculate the relative movement between two joints. For example, this is a truss. This is a hinged end. This is a roller end. Suppose there is a member, there is a joint. This is joint A and this is joint B. Due to some reasons, lack of heat or temperature change, whatever be the reason is, there is a relative movement between these, relative movement between these joints A and B. It can be, there's the two possibilities. A and B can move together and B can move apart. So, what is the relative movement between the joints A and B in the direction of AB? This is the question. Here also, we'll be applying or we'll be using the concept of unit load method. So how we'll be doing? We have to apply unit load just like this in the direction of AB. We have to apply the unit load in this way. This is one and this is one. And we'll be finding the force in various members KAB, KBC, something like that. We'll be calculating the force in every members. And ultimately, we'll be using the equation PKL by AE or K into delta dash or K into L alpha delta T to get the answer here. Okay. If I'm getting a positive answer, meaning of that is the joints A and B will be moving closer or moving, will move towards each other. If I'm getting a negative value, meaning of that is you will be moving away from it. Okay. So this is the concept of Maxwell's method or unit load method. Calculate the displacements of truss joints, vertical displacement or horizontal displacement, to find the rotation of various members, to find the relative movement between these joints. In all these cases, we can use unit load method. Everywhere we'll be using unit load method in case of trusses in order to determine the displacement at various joints. Clear, everyone? I hope it's clear. I need your responses. I need your responses. Is it clear, everyone? Is it clear to everyone? Yes, very good. We'll go to the next question. Shall we go to the next question? Yes, here is the question for you. It's a very simple question. I need your answers as quickly as possible. Read the question properly first. Read the question properly first. Yes, very good. Very good. Follow the procedure. Try to understand what he is given in the question and what he is asking us to find. It's a previous year IAS question. Understanding the concept is important, not the question. That's why I have taken this question. Just have a look at the question, try to understand what is given and try to understand what he is asking us to find. What is given in the question? Rigid cantilever beam. We are given with a rigid cantilever frame. It's called an open frame or bracket connection. Bracket, not connection, bracket. So ABC fixed at the NC. Okay, it carries a point load P at the end A. Neglecting axial deformation and assuming the flexural rigidity EI to be constant throughout the frame, vertical displacement and the horizontal displacement of the point A are. So we are interested in calculating. I've taken a general question, so the concept has to be clear to you. That's why. Not this kind of questions are not calculating both vertical and horizontal displacements without giving an option is actually not possible. Why? Because we are given with L values and H values, not 2 meter or 4 meter. Magnitude is not given there. So we have to consider it for understanding the concept. We are interested in calculating the vertical displacement of the joint A and horizontal displacement of the joint A. As I told you, I used to say it in the class. When we are asked to calculate the displacement of truss joints, we will be using unit load method. But it is not the same in case of rigid jointed plane frames. Of course, you can use unit load method here, but I will recommend you to do or use Castigliano's theorem here to find the displacement. So as we know, the strain energy stored in this member. That's how we'll use Castiglione's theorem, right? What is the strain energy, or the strain energy will be, is it due to axial deformation here? Strain energy here in this frame is not due to axial deformation. Strain energy stored in this member will be due to U is due to bending. Correct or not? Strain exactly. Strain energy will be due to bending. Strain energy here will be due to bending. How to calculate the strain energy due to bending? It will be integral 0 to L mx moment at the section x whole square divided by 2 EI into dx for a member having uniform structural rigidity. I value will be constant, right? So this is the equation for finding the strain energy stored in a member in due to bending. Here, similarly, we can calculate. You can directly apply the Castiglione's theorem here. What will be getting? Delta integral 0 to L 2 mx divided by 2 EI into tau mx divided by tau w into dx will be the equation. Ultimately, delta value will be equal to integral 0 to L mx into tau mx divided by tau w into dx. This will be the equation for finding directly displacement at various rest joints. Calculate the mx value for various members, calculate mx by tau mx by tau w, and get the delta value. Let us use this equation directly, get the answer here. Let us try this question. First of all, let us calculate the vertical displacement. I need each and everyone to try this. Very, very important concept. Let us first calculate the vertical displacement here. I'll write it horizontally. I need you to calculate vertical displacement. First of all, what you have to do? This is member AB. This is joint C. How to do it? Yes. First of all, I'm going to consider member AB. If I consider the member AB, I'm considering a section here, then it's the distance XX. This is the load acting at a distance X from this end. Mx value will be equal to P into X, and we need to calculate tau mx by tau P. Here P is the load here, right? It will be equal to X, and we know mx into tau mx by tau P will be equal to Px square. This is for the member AB. And similarly, we can consider member BC. We need to consider the free body diagram of each member. If we consider member BC, what you'll be seeing? I'm seeing a vertical member here. One end of the member is fixed. This moment or this, give me a second here. This is the vertical member. This end is fixed. This is C. This is joint B. You know this P value. The P has an effect at this joint somewhat like this. This is the value P. It will be creating a moment here also, that is P into L. Distance length of this member is H. So if I consider a section here which is at a distance X from this end, mx value will be equal to P into L, and tau mx divided by tau P value will be equal to L. Ultimately, mx into tau mx divided by tau P will be equal to P into L square. So half of the job is done. Now what we have to do is we have to apply it in the equation to get the answer. Delta value will be equal to, for member AB, the distance is 0 to L. Mx here is Px square. So mx into tau mx by tau P is Px square. I can see some of you, yeah, Krishna is giving me the answer there. Let me see. So Px square divided by Ei will be the delta value for the member AB into dx plus integral 0 to, it is L, it is H. Length of the member BC is H. So for BC it is 0 to H, limit is 0 to H, and mx into tau mx by tau P is PL square divided by 2EI, sorry, it is not 2EI, it is EI. Which equation am I using? I'm using the direct equation for calculating the displacement. So here it will be coming, it will come out to be Px cube divided by PEI, limit is 0 to L, plus EL square x divided by EI, limit here is from 0 to h. So it is PL cube divided by PEI plus EL square h divided by EI. This is how it goes. And if I want, we can calculate, we can take PL square by EI outside. So you'll be getting it as somewhat L plus PH, I think. You can just confirm it. You can just confirm it. L square divided by EI, taking it outside, L by 3 plus H, L plus 3H divided by 3. Yeah, of course. So this will be the answer. This will be the delta vertical displacement at point A. Simple integration, not difficult integration procedures are not involved there. Very easy. Calculate the vertical displacement. And if you are not interested in the, in this integration, you can simply use these equations, right? We know what is the strain energy stored in these members, right? What is the strain energy stored here? Exactly, a B. Very good. What is the strain energy stored in this cantilever beam subjected to a point load here? What is the equation? Equation is, if this is W, length of the member is L, this is W square L cube divided by 6 EI will be the strain energy stored. And here it is, strain energy stored will be equal to, intensity is small w, then it will be equal to capital L square W square L cube divided by, it is 40 EI. Very good. And here also, if it is W, strain energy stored will be equal to W square L cube divided by 96 EI will be the strain energy stored. Here, the intensity is small w, equation will be equal to W square L cube divided by 240 EI. And here also, the strain energy stored will be equal to M square L divided by 2 EI. Remember all these equations, it will be helping you a lot in saving time. Just like I'm going to tell you this now. Yes, Kasturidas is telling me W square L cube divided by 5. W square L raised to 5. Kasturi, I have taken the total load here. If I'm taking the intensity here, equation will become small W square L raised to 5 divided by 40A. That's the difference. Okay, that's the difference. That's how it is coming out to be L cube. If I'm taking total load here, that is total W, it will come out to be W square L cube divided by 40A. If I'm taking intensity, it will come out to be, it will be W square L raised to 5 divided by 40A. Is it clear, Kasturi? I think it's clear, right? Yeah, very good. How I can use the standard results here? How I can use the standard results here to save our time? You can see here, I'm going to write it here. See, AB portion, it will be, or it is behaving like a cantilever. It is, this joint is rigid. It is behaving like a cantilever subjected to a point load at the end. What is the strain energy stored? You know the equation. Just now we have seen this. It is W square L cube divided by PEI. Right or not? Strain energy stored in this member. And similarly, for this member BC, BC will be somewhat like this, correct? There is a load. The axial deformations are not considered here. This is P into L. It is almost like this, right? Cantilever beam subjected to bending moment. Yeah. The strain energy stored in this member BC will be equal to M square L divided by 2EI. M square is P into L. That is P square L square into L. L here is H divided by 2A. The total strain energy stored will be equal to U. Total strain energy stored will be equal to what is the total strain energy stored? P square L cube divided by TEI plus P square L square H divided by 2EI. This is the total strain energy. If you take the partial derivative of tau u by, viewed with respect to W, you'll be getting the displacement. We will be getting the vertical displacement as P square L square, PL square by PL square divided by PEI into PL, 3H plus L. You'll be getting the same answer there. So what I'm trying to say is, if you have to remember these standard results, and again, you'll be getting direct questions from this. You can get, or there is a possibility of getting direct questions from this standard results. Why I'm telling this standard results? Why? Because it is going to help you a lot in solving many questions in their exam. That's why I'm telling you this. Cantilever beam subjected to point load, cantilever beam subjected to what to say, UDL, cantilever beam subjected to moment, simply supported beam subjected to bond load, and simply supported beam subjected to UDL throughout. Remember these results, which is going to help you a lot in finding the equations, finding the answers. Okay. Again, if I need, that was not the end of the question. I was interested in calculating the horizontal displacement as well, right? Horizontal displacement. Can I use Castiglione's theorem here? Will I be able to use Castiglione's theorem here? Will I be able to use Castiglione's theorem here? So, then which method will I be using? I will be using exactly just like Vaishnavi told me previously. We'll be using fictitious load method here or imaginary load method. We'll be using imaginary load method, where in this structure I need the horizontal displacement of the joint A. There is no load acting at the joint A. That's the reason why I am going to assume a load in that direction where we need the displacement, in the direction in which I need the displacement. I need the horizontal displacement of the joint A, so I am going to apply one horizontal load at the point A, at the joint A, at the point A in the horizontal direction. So that is our fictitious load. Now what we have to do? We have to follow the same procedure. First of all, consider member AB. You people also can try this. I am expecting you people to try along with me. This is P, and of course, this is the fictitious load F. This will be, let us say, X. Mx will be equal to P into X. Should I consider tau mx by tau P? No, I should not be considering this. If I consider tau mx by tau P, I'll be getting the vertical displacement. As I need to calculate the horizontal displacement, so I have to consider tau mx by tau F, which will be equal to 0, which means mx divided by mx into tau mx by tau F will be equal to 0. And let's consider other member. Consider member BC. If you consider member BC, what you can observe, you can see one vertical member here. Okay, and one end of the member is fixed, and there is our fictitious load. There is the vertical load applied, and this is the moment due to our vertical load, that is P into L, and length of the member is H. What is mx? Mx value will be equal to PL plus F into X, and tau mx by tau F value will be equal to X, and mx into tau mx divided by tau F will be equal to ELX plus Fx square. And we know the equation for finding the horizontal displacement at the point A. That is point A, right? Not C. Yeah. It's a vertical horizontal displacement of the point. We should not consider the member AB. Why? Because it is already 0. Mx into tau mx by tau F value is already 0. So we don't have to consider that. Remaining is integral 0 to h. Tau mx by tau F value will be ELX plus Fx square divided by EI into dx. But remember, after the derivation, after the differentiation, before integration, we have to set the fictitious load value to 0. The fictitious load is also, it's not there. Fictitious load is not there. We assumed it, right? So before the integration, after the differentiation, we have to set the F value as 0. Remaining is integral 0 to h ELX divided by EI divided by EI into dx. So it will come out to be EL h square divided by 2EI. Got the point? I think Kasturi, you have taken the length here as L, I think. This is how we will be calculating the equation. We will be calculating the horizontal displacement. If there is no load acting in which we need the displacement, we will be assuming a fictitious load in that direction. That's what we are going to do. That's what we usually do. So this is a very important concept. You can see many number of questions from this. Many number of questions are there. See, understand the concept. It's not the question given. Understanding the concept is important. How we can use the standard results, that's also important. How we can use Castiglione's theorem, that's also important. So I think it's clear, right? Usage of Castiglione's theorem to get the horizontal or vertical or even rotation also can be calculated. How to calculate rotation if that is there? You have to use tau u by tau m. I will be giving you the rotation. What's the point? Shall I go to the next question? Shall we go to the next question? Respond, please. I need your responses. Here is the next question for you. Go for it, please. I will give you some time. Puja, Kasuridas, Abhi. Those who are present here, just please respond here. Try to solve this question. This question is from the Aptitude moment distribution method. Try to solve them. Try to solve it. It's very easy, and similar kind of questions are very common, and you can see many number of questions from this concept. Many number of concepts are there. Many number of concepts are involved in this particular question. Read the question properly. Follow the procedure. Read the question properly. Understand what is given in the question, and try to understand what he is asking us to find, and try to think how we can get the answer. Expecting your answers. I'm expecting your answers. I'm giving you some time. Right. It's very good, Krishna. Very good. Very good. Superb. 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 I'll read the question for you. Others can try. Others can try. Those who are not comfortable with this concept, you can just have a look at it. Right. So you cannot the answer is 2 by 19. Okay. We have to report our answer just like this, out of 2 decimal places. Read the question for you. What he is asking us to find, and how we are going to get it, and what are the things given in the question. See, the rotation of the joint B is what we have to calculate. Of the rigid jointed plane frame shown in the figure below is given as it's also given. It's given as x into ml divided by a. And the value of x is, he's not directly telling us to calculate the rotation of the joint B. Is given as the rotation, and he is asking us some value there, this x value. He is asking us to round it off to decimal places. So how we should be calculating it? In order to calculate in order to approach, in order to solve questions of this kind, we have to use this concept. Which concept? Stiffness of the joint. Stiffness of the joint is defined as the moment required for the unit rotation of that joint. Stiffness of the joint will be equal to moment applied at that joint divided by rotation of that joint. What is the moment applied at the joint B? The moment applied or moment at the joint B is already given in the question, that is m. And AB we have to calculate. Theta B we have to calculate. These are the 2 unknowns. Theta B I don't know. We don't know the value of KB, the stiffness of the joint B. KB is the thing which is asked in the question. Forget about that. Let's think about this one. This KB value. How to calculate this? Theta B is asked in the question. Forget about that. We are interested in KB value. Let's think how we can calculate theta KB value. Very good, yeah, very good. So how to calculate KB value? We have already studied that. We have also studied stiffness of the joint B. Stiffness of a joint is the summation of the stiffnesses or the members meeting at that particular joint. Or not? We have also seen that stiffness of a joint is the summation of stiffnesses of the members meeting at that particular joint. That means here BA, BC, BD are the members meeting at that particular joint B. AB will be the summation of stiffnesses of the member BA, BC, and BD. Now comes to the next question. Coming to the next question. How to calculate the stiffness of various members? It depends upon the foreign conditions. If the foreign condition is fixed, if the foreign is fixed, what will be the stiffness? Stiffness will be equal to 4EI divided by L. Stiffness of for the member BC. For member BC, this is the near end where the moment is applied. C is the far end. The far end is fixed. The far end is hinged here or roller here. What is the equation? Is 3EI divided by. For the member BD, what is the stiffness? Is 4EI divided by L. There is a possibility of mistake, making a mistake. What is the possibility of mistake? Length of the member for the member BC is 2L, it is not L. Length of the member is given as 2L, it is not L. So be careful at that point. So total will come out to be 9.5 EI divided by L. This will be the KB value. Some of you will be directly writing it as 9.5. We'll be directly seeing the equation here. Acha, x into something like L by EI. Okay, answer will be 9.5. Don't be careless in the examination. He is not asking this one. He's asking us the rotation. What is rotation? We have calculated the KB value. We know the MB value. Now calculate the theta B value by dividing MB with KB. What is MB? That is M divided by 9.5 EI divided by L. Or I am going to write it like ML divided by 9.5 EI. So 9.5 is in the denominator. If I'm taking it the numerator, it will come out to be 0.108 ML divided by EI. So this is the X value. X value can be reported as 0.10, something like that, 1011 or 108. You can put the answer something like this. This will be the X value there. This will be the X value, and this will be our answer. This will be our answer. See, different different kinds of questions are possible here. Sometimes now you will be asked to calculate the stiffness of the joint. You can calculate it KB value. Sometimes you will be asked to calculate the distribution factor. How to calculate the distribution factor? If I'm asking you the question, what is the distribution factor for the member BA? I'm going to denote it with the letter DFBA. How to calculate the distribution factor for the member BA? How to calculate the distribution factor for the member BA? KBA, stiffness of the member BA divided by stiffness of the joint. This is how we will be calculating the distribution factor for the member. KBA is known to us 4A by L. Total is known to us 9.5A divided by L. 4 by 9.5 will be the distribution factor. So such kind of questions are also possible. Yeah. Yes. So I think it will come out to be 0.42. As per Kasturidas, I'm going with his answer. Others can confirm this. It will come out to be 0.42. Okay. Yeah. And again, more we can frame more number of questions from this. I can frame more number of questions from this. Suppose if I'm taking a structure somewhat like this, and I'm taking a hinge here. Suppose there is a hinge support. Okay, let's take support here. Okay, and I'm taking taking hinge support here. This is L and this is also L. They can give you the moment here, let's say 20 kilonewton meter, and they can ask you the rotation here. This is A, this is B, and this is C. They can simply ask you the rotation at the end B. Okay, and similarly they can ask the rotation at the end A also. How to calculate the rotation of the end A? Anyone? I'm giving you more concepts. Okay, to understand the concepts. Theta B can be calculated in this way. And in order to calculate theta A, we need to write the slope deflection equation for the member AB or BA. Slope deflection equation. What is slope deflection equation? MAB is equal to MFAB. As there is no load on this member, MFAB will be 0. 2EI by L into 2 theta A plus theta B will be the MAB value. We know MAB is already 0. Theta B can be calculated by the same procedure. From this, only the unknown will be theta A. Theta A and B A can be calculated. Got the point? Sometimes you will be asked, what I'm trying to say here is, sometimes without asking, instead of asking theta B, they will be asking you theta A. If you want to calculate theta A, you can follow the same procedure. There will be using the concept of moment distribution, you will be using the concept of slope deflection. Get me point? Exactly, Krishna. Very good. So this is also possible. Again, if you want, I can discuss something more here. Again, gate questions are there from this. Suppose there is a structure somewhat like this. This end is fixed. Of course, this let us also consider this point is also fixed. There is a gate question. You may be familiar with the gate question, so I'm taking a different kind of loading here. Suppose there is a loading given here. I am considering a uniformly varying load. Right. So this is a uniformly varying load acting on this member. It's a member, okay? It's a member. This is a joint B. And let us say this is A, this is C, and finally this is D. And you will be asked to calculate theta B. How you will be calculating it? The previous two cases, we were given with theta, I mean moment at the end B. Here also moment was given. Here also moment was given. Here moment is not given, but you are asked to calculate theta B. How to calculate it? How to calculate it? Exactly, very simple. Convert this entire load into moment. Convert the entire load into moment. How to convert it? You know how to convert the moment, right? Intensity half into W into L into 12 divided by 3. Right? Convert it into moment and get the answer. That is what you have to do. You can see there can be some combination also, just like it was given in our gate question. In gate exam, it was given somewhat like this. This kind of questions are also possible. You have to understand this. There was one member here and one more member here, and one point load was acting in this direction, and one more point load was acting in this direction. So it is uniformly distributed load, and one more point load was acting in this direction. See how I can make the structure a bit more complicated, right? Loading is given 20, let us say 10 kilonewton per meter. Suppose this is a 20 kilonewton. Have to be very careful about the type of nature of loading. Some loads will be creating clockwise moment at the about this point. Some loads will be creating anti-clockwise moment. For example, the point load here will be creating a clockwise moment, correct? The UDL will be creating an anti-clockwise moment. And the point load here, this one will also be creating an anti-clockwise moment. So the nature of moment is also important. Sometimes in the option, theta B value will be given as something like this. Maybe who knows, 0.01 radians, but in the clockwise direction. 0.25 radians. It is in the anti-clockwise direction. If direction is also involved, the direction of moment will also be important. And of course, if you are not considering the direction of the moment, clockwise or anti-clockwise, you will not be getting the correct bending moment at this point. The point. You have to be very careful about the type of loading given in the question. And this is a very interesting question and very important too. Many gate questions are there. Okay. Many gate questions are there. I think this concept is clear, everyone. Is it clear to everyone? How to calculate the theta B, and if sometimes how to calculate the theta A value. Clear to everyone? Clear to everyone? Yes. And of course, some more concepts are there. Just like our Krishna said, you are already aware of this, right? Sometimes many number, as I told you, many number of concepts are available here, right? Sometimes they will ask you calculate MBD. Sometimes they will tell you to calculate MBD. Sometimes they will calculate, MBC or MBA, somewhat like this. I'm going to group it into one category. Sometimes they will ask you to calculate MA. Sometimes they will calculate MD. Sometimes they will tell you to calculate MC. How to calculate it? See, this moment applied here, the entire moment will get transferred to the members meeting at that joint, right? In the ratio of the distribution factor. Which means if you want to calculate MBD, you have to multiply the distribution factor for the member BD with the moment applied at the joint B. Getting my point? Entire moment, which was the total moment M, will be transferred to the members meeting at that particular joint in the ratio of the distribution factor. If I think Kasturidas was giving me the answer, no one has I think confirmed the answer. The distribution factor for the member BA is 0.42. If the distribution factor for the member BA is 0.42, the meaning of that is MBA will be equal to 0.42 M. 0.42 M is the moment applied at the joint B. So this is the meaning of it. And remember, based on the foreign conditions, some of this moment which is transferred to this member BA will be occurring in the end joint A as well, which is known as carried over moment. Generally, this is the moment applied, moment transferred, and this one is moment carried over. Moment carried over based on the foreign condition. If the moment, if the foreign is fixed, half of the moment will be transferred. It will be 0.21 M. Getting the concept? Carryover factor. Based on the foreign conditions, some moment will be transferred. If the foreign is fixed, half of the moment will be transferred there. Clear? Such kind of concepts are also possible from this question. Okay, they can ask anything. They can ask you anything, any questions. They can ask you any question from a single structure. Only one structure was given, but think how many questions were possible. Theta B, theta C, and MBA, MBC, MBD, then distribution factor questions. And of course, sometimes they can ask you the ratio of distribution factors. DBA and DBC, ratio of DBA to DBC, you can calculate it. So different kind of questions are possible. What is the carryover factor? What is the carried over moment at the end? MA, MB, sorry, MC, MD, something like that. Okay. So this is how it goes. Have a look at this question. This question, very, very important. Okay. I think we can go to next question. Read the question here. I have not given a question here, but I'm going to ask you, I'm going to tell you to do something here. Okay. This is a beam given in our question, and I want you to draw the influence line diagram for various force functions. Okay. I'm not given a question here because I am not interested in giving an option at all, but I want you to draw it on your paper, and I want you to tell me whether it is correct or not, and think the concept you have applied is correct or not. Okay. First of all, what you have to do is I want you people to draw ILD. I want you people to draw the ILD for the vertical reaction at A. Can you draw it, please? ILD for vertical reaction at A. Before that, before doing that, tell me which principle are you going to use here to draw the influence line diagrams? Very, very important question here. Very, very important. Super important topic from structural analysis. Super important topic. Yes, which principle will I be using? Will we be using to calculate or to draw the influence line diagrams? Kasturi is asking me, telling me my doubt. Kasturi, can you just repeat your doubt? I'll take it towards the end of the session. Okay. Yes, Muller-Breslau principle. Very good, Vikas. Muller-Breslau principle. Then the next question will be, what is Muller-Breslau principle? Muller-Breslau principle will be helping us to draw the influence line diagrams for various functions in a structure. Structure can be a beam or it can be a frame. It can be a simply supported beam, cantilever beam, fixed beam, continuous beam, whatever be the beam structure given there. It will be helping us, or it is a tool to draw the influence line diagrams. Here we are given with a continuous beam, and we are asked to draw the influence line diagram for RV. I'll tell you why we are drawing this influence line diagrams in the coming, within a few minutes. So first of all, what we have to do, draw the influence line diagrams. Suppose I have a structure here. I think you'll be able to see this. Okay, I'll draw it here. I have a simply supported beam here. And this is NA and this is NB. I am interested in interested in drawing the influence line diagram for vertical reaction at the end. First of all, what you have to do is, we need to release the vertical reaction at the NA. This is how we will be releasing the vertical reaction. And after releasing the vertical reaction, I have to give a unit displacement in the direction of the released force component, force function. Reaction was in the vertical direction. I have released it. Now I have to give a unit displacement, and I have given a unit displacement. The structure will come here. We are having a roller there, right? The structure came here. So now this is the beam, and this displacement here is 1 unit. This is the deflected profile, correct? And this deflected profile will represent the influence line diagram for that particular force function. Here in this case, it is Ri. Give me a point. How to draw the influence line diagram? How to find the influence line diagram? How to draw the influence line diagram? First of all, force function for which we need to draw the influence line diagram. Consider that. Place that force function. Apply a unit load in the direction of that force function and draw the deflected profile. Get the influence line diagram. This is the concept behind concept of Muller-Breslau principle. Draw the influence line diagrams. Keep it in your mind. Remember, for statically determinate structure, influence line diagram will be linear, and for statically indeterminate structures, influence line diagram will be non-linear. Coming to this question, we are interested in calculating, or we are interested in drawing the influence line diagram for vertical reaction A. I'm going to release the vertical reaction here. Okay, I have released the vertical reaction. After releasing the vertical reaction, what I have to do? I have to give one unit displacement. This point came here. This point is coming here. After that, what you have to do? You have to draw the deflected profile. The beam is going to deflect somewhat like this. This is a hinge given, right? This is a hinge given. This will be coming here. And what will happen to the remaining portion of the beam? Yes, this member will also be rotate. This member will also rotate about this support. This is how the beam is going to deflect here in case of ILD for reaction at A. This ordinate here will be equal to 1. You can easily calculate the ordinate here. What will be the ordinate here? If I am taking it as y divided by 2 will be equal to 1 divided by 4. Y will be equal to 0.5. You can use similar triangle concept here, similar triangle principle here. Find the ordinate of influence line diagram at various points. Is it clear? How many of you got the correct answer here? How many of you have drawn this correctly? ILD for reaction at A. ILD for reaction at A. This is how the ILD for reaction A will look like. Perfect. Perfect. Very good, Kasturi. Very good. Very good. This is the ILD value. Right? And again, if I'm asking you one more question, I want you to draw the ILD for RB. Can you do it? I draw the ILD for RB. Understand the procedure, what we have to do. Understand the procedure, what we have to do. Draw the ILD for RB. First of all, release RB, then give a unit displacement in the direction at the point of that force component, and draw the deflected profile. That's what you have to do. Do it fast. Do it fast. Want each and every one of you to draw the ILD for RB. RB. I'm assuming that you people are drawing this ILD. If you are comfortable with the Muller-Brushley principle, it's a matter of seconds. So first of all, what we have to do is we have to release the reaction here. Critical reaction is released, and after that, I need to give a unit displacement. Put it here. So this came here. This value here is 1. Now we have to draw the deflected profile. This entire member will come here. The entire member will reach here. Correct. This point came here. Let us say I'm going to call it as B dash, and this hinge will be coming here. Now what will happen to the remaining portion of the beam? It will rotate. The remaining portion will rotate about this hinge. This will come out to be somewhat like this. This is going to be the ILD. This is going to be the ILD. What is the ordinate here? If I'm taking it as y, you can find it by using similar triangle principle. It will be coming out to be 1.5. Y divided by 6 is equal to 1 divided by 4. Y is equal to 6 divided by 4. That is equal to 3 divided by 2. It's equal to 1.5. Sometimes now you will be getting the questions like this. What is the ratio of the ordinates at the point B and E in the influence line diagram for reaction at B? This kind of questions are also possible. Okay. You can find and tell me what is the coordinate here at that point D. Okay. How many of you have drawn this correctly? LD for reaction B. How many of you did it correctly? LD for reaction B. Assuming that most of you might have drawn this correctly only. Right? Yes, very good. Pooja, very good, very good, very good. No, it's a very common question. Okay, it's a very common question, and you'll be getting questions from this topic. Okay. Next, I'm extending this question further. I want you to draw the ILD for RC. I will also draw along with you. I need you to draw ILD for RC. First of all, release RC. Now, what we have to do? Give a unit displacement in the direction of RC. If I am giving a unit displacement in the direction of RC, what we have to do? This point will be coming here. Correct or not? This point will be coming here. How the deflected profile will be? Deflected profile will be somewhat like this. There will not be any change in the remaining portion. Remaining portion will remain as it is. Why? Because there is a continuity in this member. There will not be any change in this member. It will be somewhat like this. If I am applying a moment here, I will load here, it will behave like this. No change will be there in the remaining portion. This is a hinge, right? Hinge is attached somewhat like this. If I am applying a unit displacement here, it will go like this. This will be the deflected profile. LD for RC. You can find the ordinate here. What is the ordinate there at YD? YD divided by 5 is equal to 1 divided by 2. YD can be calculated 5D divided by 5 divided by 2, which is basically 2.5. This is how we calculate or how we draw the influence line diagrams. Okay. Yeah. Everyone. Perfect answer. Now, if you are interested, we can move further. There's a hinge here. I'm telling you the possible questions. Okay. We can draw, suppose if I'm taking a section here, this is suppose 1 meter and this is 3 meter. Okay. I want you to draw the influence line diagram for bending moment at section XX. This is section XX. I want you to draw the influence line diagram for bending moment. How it will be? How it will be? It will be somewhat like this, correct? 1 second. ILD for bending moment will be somewhat like this. This is AB by L. And of course, this portion will be rotating about this roller. This will be the hinge. And remaining portion, yes, remaining portion will be somewhat like this. You can find the ordinate at each point. What is the ordinate here? Ordinate here will be equal to AB divided by L. 1 into 3 divided by L, there is 4 meter. So 3 by 4 will be the ordinate. Correct. ILD for not bending moment at C here. I'm asking about the bending moment at XX. Okay. Similarly, we can, if you want, you can draw the ILD for that shear force as well. It will be somewhat like this. You can draw it. I'm not going to draw it, but you can think about it and you can draw. It will be somewhat like this. I'm leaving it for you. Okay. See, the question is why we are drawing all this. Why we are drawing all this? Why we are drawing the influence line diagram for? See, this is the ILD for bending moment at section XX. This is the section XX, and this was the ILD for RC. This was ILD for RC. That is the reaction at C, and this is ILD for RB, and this is ILD for RB. Suppose see, there is a load. There is a load acting here. There is a UDL. Okay, there is a UDL. Suppose this is the UDL. I am telling you that this UDL is longer than the span. This UDL here is longer than span. Let us say the intensity of UDL is around 10 kilonewton per meter. What is the purpose of drawing ILD? You have to understand this. Okay. You have to understand this. What is the ILD for reaction? Sorry, why we are drawing influence line diagrams? Purpose of drawing influence line diagrams is to, of course, as the name says, to see the influence of loads or moments on various stress functions, force functions like reactions, bending moment, or shear force at various sections, etc. So here, what I'm trying to say is, I'm asking you, this UDL is longer than the span. So this is what is the maximum reaction at the point? Sorry, what is the maximum reaction at the support C due to a moving load of 10 kilonewton per meter, which is longer than the span? If this is the question, what you will do? Question is, what is the maximum reaction at the support C due to a moving UDL of magnitude 10 kilonewton per meter longer than the span? What is the procedure? I'll repeat. What is the maximum reaction at the point at the support C due to a moving uniformly distributed load of magnitude 10 kilonewton per meter, which is longer than the span in kilonewton? What will be your answer? How to calculate it? First of all, we have to draw the influence line diagram for RC, and we have to see the position of the load to get the maximum value. If we place the UDL here, this is 10 kilonewton per meter, and this will be the position of the UDL to get the maximum reaction at C. What is the maximum reaction at C? Maximum reaction at C will be equal to area of ILD into intensity of UDL. Remember this. Instead of this, if it was a point load, where the position of the point load? Instead of this UDL, if it was a point load of certain magnitude, where we should place the unit load? Should I place the unit load here at the point E, or should I place it at EC, or should I place it at D? Where should be the position of unit load position of the point load. Instead of this UDL, suppose there is a point load of around 100 kilonewtons moving on the girder, moving on the beam. Where we should be keeping the point load? Will I be keeping it on the point E, or will I be keeping it on the point C, or will I be keeping it on the point D? Where we will be getting the maximum point? Where will be getting the maximum reaction? Where I'll be getting the maximum reaction? Yes, if we, instead of this UDL, if I'm having only the point load, I'll be getting the maximum reaction when the unit load is here. Why? Because in case of UDL, it is area of ILD into intensity. In case of point load, it is magnitude of the point load into ordinate. So in this ILD, where we are having the maximum ordinate, at D we are having the maximum ordinate. So that's the reason why the position of the point load should be at the point D to get the maximum reaction at the point C. Draw the ILD for RC first of all. After that, check whether where we will be getting, or find where the what should be the position of the load, so that we will be getting the maximum value of that particular force function. This is the reason why we are drawing the influence line diagrams. First of all, we need to see the influence of that influence of those loads on the structure. Secondly, we have to see the position of various loads on the structure to get the maximum values of particular force functions. And of course, we have to calculate the maximum value of those force functions as well. Right? Similarly, if I ask you, what is the maximum value of or negative reaction? Maximum value of negative reaction at the point B. What is how to calculate the negative reaction here? First, draw the ILD for RB, and where this portion here is negative and this portion here is positive. However, when I will be getting the maximum negative reaction, when the UDL is going, when the UDL is on the span CD, I'll be getting the negative reaction, maximum negative reaction at the point at the low at the support B. Got the point? Exactly. And what should be the magnitude? UDL, intensity of UDL into area of this portion. How, when I'll be getting the maximum positive reaction at the point B? When I'll be getting the maximum positive reaction at the point, what should be the position of the load? Should I place it between AB, AE, or CE, or AC? What should be the position of the UDL to get the maximum positive reaction at the support B? Where we should be placing it? UDL. I'm not asking about the point load, Krishna. UDL. Yes, UDL should cover the entire AC span. UDL should cover the entire AC span. If when the UDL start occupying this CD span, it will start decreasing. When we will get the maximum positive value? When the UDL is on the span AC. Got it? So it depends. You have to check it. You can check it. You can compare. You can consider first AA. You can consider AC, and you can calculate it and tell me. Okay, it will be in the span AC. So this is how we will be using Monroe-Presley principle. This is how we will be using influence diagrams to solve the questions. It's actually such kind of questions are very common. Okay, that's why I'm discussing it, and it is very interesting too, and it is very easy for you to get the answer if you know this concept. Okay, so this is all about that question. I hope it was clear. See, there is one more question. I want you to solve this. Okay, this question is from the chapter Analysis of Arches. I want each and every one of you to try this, and I want you to give me the correct answer. I will give you some time to solve this question. Get me the correct answer. Understand what is given in the question, understand what he is asking us to find, and think how we can solve this, how we can find it. To do it, everyone. I'll give you some time, maybe 1 minute. Give me the answers as quickly as possible, without any errors. Third hinge is at the crown. Krishna. Here we are having the third hinge at the C. Okay. I hope you people are solving this. Let's start solving this. Yeah. So what he's given in the question? He is given with a three-hinged arch. Supports are at different level. Reaction at support A. So we have to calculate the reaction at support A. When we are getting a question like this, is he asking about the vertical reaction or horizontal reaction? Tell me this. He's asking us to he's asking us to calculate the vertical reaction or horizontal reaction. When we simply ask you the reaction at support A, that's a point where you do the mistake. Okay. We simply ask you the reaction at support A, you have to calculate the resultant reaction, not the vertical reaction, not the horizontal reaction. Of course, you have to calculate both to get the resultant reaction. Okay. Vikash and Kushbu, mistake you have made. Okay. When you are asked to calculate the resultant reaction, sorry, reaction simply at a support, you have to calculate the resultant reaction, not simply the vertical reaction or the horizontal reaction. Okay. We are given with a three-hinged arch shown in the figure below. Supports are at different level. Distances are also given. Options are also given. It's a MCQ type question. Now what we have to do? First of all, let us consider or let us take moment about NC. The moment about C. I'm going to call it as sigma MC, which will be equal to 0. Let's do it from left hand side. Okay. Let's just. What are the forces creating moment there? See, at this support, I will be having some vertical reaction. I'm going to call it as VA. And there will be some horizontal reactions as well. I'm going to call it as HA. I'm not going to call it as HA and HB. Why? Because horizontal reactions will be same. Okay. There will be horizontal reaction here as well. This is also H, and there will be vertical reaction here. I'm going to call it as VB. These are the reactions at various supports. These are the reactions at supports. VA, VB, HA, and H at B. Now, if I take the moment about C from the left hand side, what are the forces creating moment? VA will be creating moment. VA into 4 is the moment created by the load or reaction VA. Similarly, I'm taking clockwise moment as positive. With the assumed direction VA is creating a clockwise moment there. So H will also be creating a moment which is anti-clockwise in nature. So minus H into 4 will be the moment created by H will be equal to 0. From this we can easily say VA is equal to H. VA is equal to H. Simple, right? VA is equal to H. This is, let us say, equation number 1. And if I take sigma MC is equal to 0 again, but this time from the right hand side. What are the forces creating moment about point C from the right hand side? VB is creating some moment, but it is in the anti-clockwise direction. Let us say VB into 6 anti-clockwise. H here will be creating a clockwise moment about the point C. So H into 6 will be the moment, total moment will be equal to 6. Here also I can see one point, that is VB is also coming out to be H. This is equation number 2. What we are basically observing here, VA is found to be H and VB is also found to be H, which means let us say VA and VB both are equal. Right? Total load is W, both are equal means it will be W by 2, which will also be equal to H. What we are finding or what we are seeing here is VA value, we are asked to calculate the reaction at the end A, right? VA value here is W by 2 and horizontal reaction value here also W by 2. Total reaction or reaction at the end A will be the resultant of the vertical and horizontal reaction, which means square root of VA square plus J square. So it will come out to be root of W by 2 whole square plus W by 2 whole square. What is the answer? W by root 2. Which is our correct option? Option A will be correct. You know why they have provided this W by 2? Some of you will stop doing calculation after finding this VA value. That's the reason why option C is there, right? So if they're asking, simply asking you the reaction, go with the resultant reaction, don't go with the vertical or horizontal reactions. If they're asking you horizontal or vertical reactions, they will ask you specifically. Okay, they will ask you specifically. Okay. Yeah. I'll ask you one, I'll tell you some more concepts. Again, there was a question. Let me draw that. Arch here properly. 1 second. This is a semicircular arch. Okay, let me draw it. Let me draw it first. I want this to be a semicircular arch. I'm drawing this. Okay. So this is a semicircular arch, and this is 2-inch semicircular arch. This is a 2-inch semicircular arch, and this is the crown. And there is a point load acting here. Let us say this is 50 kilonewton, and there is one more point load acting, which is acting at an angle 60 degree. Let us say the magnitude of that, which I'm going to consider it as 100 kilonewton. I'm asking you, what is the horizontal reaction at the end A? This is the A. This is A, and the shape of the arch is given as semicircular. Semicircular. Calculate the horizontal reaction at the end A. For this, what you need? For this, what you need? The 2-inch semicircular arch, right? It's a 2-inch semicircular arch. Yes, Krishna is giving me the answer as 40.91. Let's see. It's a concept which is important, Krishna. Okay. Of course, answer is also important, but I am more interested in concept than the answers. If it's a semicircular arch, it's a 2-inch arch. How to calculate the horizontal reaction? How to calculate it? See, we have to remember some horizontal reaction equations for getting the answers as quickly as possible. The arches can be of different types. Based on the shape, we can classify them as parabolic arches. We can classify them as semicircular arches. We can classify them as segmental arches, like that. And based on the number of hinges present, also we can classify the arches like 2-inch arches, 3-inch arches, single-hinge arches, fixed arches, somewhat like that. 2-inch arch is important for us, and 3-inch arch is also important for us. So, what are the standard results? You have to remember this, very, very important. Suppose if I'm having a 3-inch parabolic arch, I'm talking about parabolic arches, okay? I have a parabolic arch. You can tell me the answer here. If a parabolic arch is there, this is a parabolic arch, 3-inch parabolic arch. What is the horizontal reaction? What is the equation for finding the horizontal reaction? What is the equation for finding the horizontal reaction? This is WL divided by 4H. If the rise of the arch H and the span of the arch is L, correct or not? Agree with me or not? Horizontal reaction support will be equal to WL divided by 4H. Similarly, if this is a 3-inch parabolic arch, yes, exactly, 3-inch parabolic arch subjected to UDL throughout, what will be the horizontal reaction? Horizontal reaction will be equal to WL square divided by 16H. Similarly, again, we need to remember this as well. What? Again, a 3-inch parabolic arch where the loading is somewhat different. Loading is now, it is UDL, it is provided with the UDL on half span. Then the 3-inch parabolic arch, okay? Horizontal reaction will be equal to, it is not 16H, it is 8H. I'm sorry for this. And here it is WL square divided by 16H. Okay. And again, we should remember all these results. We should remember all these standard results. Very, very important. Again, a 3-inch parabolic arch, subjected to uniformly varying load. Uniformly varying load, somewhat like this. This is the uniformly varying load provided. What will be the horizontal reaction here? What will be the horizontal reaction? This will be WL square divided by 16H. Very good. And this is for 2-inch parabolic arch. For 2-inch semicircular, 2-inch, this is for 3-inch parabolic arch, not for 2-inch parabolic arch. For 2-inch parabolic arch, what are the basic equations? Only this will be different. 2-inch parabolic arch subjected to central point load. Tell me the horizontal reaction here. We have studied this. We have studied the difference there. What is the horizontal reaction? Exactly. Very good. 25 WL divided by 128H. It will not be equal to WL by 4H. It will be 25 WL divided by 128H. And all other cases will remain the same. This is for parabolic arches. Very good, very good, very good. This is for two-hinged parabolic arches. But here in this question, as I told you, it's a semicircular arch. If it is a semicircular arch, what you have to do? Again, here also we have to remember this results. Two-hinged semicircular arches. Remembering these results is recommended. Why? Because questions can be easily solved if you remember these results. First of all, I have a two-hinged semicircular arch just like this. This is assume it as semicircular, okay, semicircular. And there is a point load of magnitude W. It is acting exactly at the center. Horizontal reaction. What is horizontal reaction? Anyone? Exactly, Krishna. Very good. It is W by. Okay. And if one more loading condition, for example, again a two-hinged parabolic, semicircular arch, two-hinged semicircular arch, but now the load is not acting through the center of the arch. Now it is acting at an eccentricity, at an angle alpha, let us say, with the horizontal. This is the load here. I mean, what is the horizontal reaction? It will be equal to W by pi into sine square alpha. Very good. W by pi into sine square alpha. Again, we can proceed further. Again, it is a two-hinged semicircular arch. Again, two-hinged semicircular arch, somewhat like this. And now it is subjected to UDL of magnitude W per meter. What will be the horizontal reaction? Anyone? 4R divided by 3 pi. And we can move further. It is a two-hinged parabolic arch. Again, it's not a two-hinged parabolic arch. It is a semicircular arch. UDL is provided only on the half span. What is the horizontal reaction? Is 2R divided by 3 pi. And if you need, we can move further. Right? Same equation, same. It is two-hinged semicircular arch. Assume it as semicircular. Okay. Yeah. Now it is subjected to uniformly varying load, somewhat like this. H will be equal to 2R divided by 3 pi. And again, if I need, I can proceed further. Suppose if I have a UDL, if I have a loading condition somewhat like this, this is a semicircular arch. Now the loading condition is somewhat like this. It's a two-hinged semicircular arch. Okay, two-hinged semicircular arch. There is a loading here, W1, and there is a loading here, which is W2. Okay. W2 is at a distance acting at an angle alpha. What will be the total reaction? W by pi plus W2 by pi into sine square alpha. We are applying superposition principle here. Yes, very good, very good. So this is how we will be using. This is how the horizontal reaction will be for two-hinged parabolic arches, three-hinged parabolic arches, and two-hinged semicircular arches. Coming back to our question, what is our question? In this question, we are asked to calculate the horizontal reaction. How to calculate the horizontal reaction here? Just remember the equation and get the answer done, right? Let's get the question done. So, horizontal reaction will be equal to 50 divided by pi for this load plus 100 divided by pi into sine square 60. Agree with me or not? Any suggestions? Any mistakes? Yes, there is a mistake. What is a mistake? Alpha value here is mentioned or measured from the vertical axis, right? But alpha value has to be taken from the horizontal, from the bottom, from horizontal, right? So it is 30 degree. It should not be 60 degree. It should be 30 degree. Give me the answer here. It will be 50 by pi plus 100 divided by pi. Sine 30 is 1 by 2, that is 0.5. Sine square 30 is 0.25. So 50 plus 25, I think it is 75 divided by pi. You can just correct me if I'm wrong. Okay. Horizontal reaction here will be equal to 75 divided by pi. No need to go for analysis. If you see, if you don't remember these equations, you have to analyze the structure by using strain energy principle or by using the methods available. Two-hinged arch, that is parabolic or semicircular, it is indeterminate one. You have to go for indeterminate analysis, which is a time-taking process. So remembering the standard results is actually recommended. For the one, W by pi, W by pi into sin square alpha, and 4r by 3 pi, 2r by 3 pi, all these things are there. Just remember these equations. Just remember this equation. And of course, this is also important, right? Hinged parabolic arch subjected to UDL throughout. We know the things, right? What is the vertical reaction? WL by 2. What is the horizontal reaction? WL square by 8h. What is the bending moment at this section XX? Give me this. It's a very important question. That's why I'm discussing it also. What is the bending moment that is at this section for a 3-inch parabolic arch subjected to UDL throughout? What is the bending moment? It is 0. Not even bending moment, shear force will also be 0. Only one force which is there in this structure will be what? Axial compression. No other force will be there. That's a very important thing. You can expect such that question in MSQ. Which among the following statements regarding 3-inch parabolic arch subjected to UDL throughout is correct? Option A, vertical reaction is WL by 2. Option B, horizontal reactions are WL square by 8h. Option C, bending moment at every section is 0. Option D, shear force at every section is 0. What is the answer? All the options are correct. Right? So MSQ questions are also possible. Think about all these things. So this is it. We are moving towards the end of the session. Therefore, 2-hinged bending moment at any section is 0 or WL square by 8. 2-hinged, you're talking about 2-hinged. It will be 0 for parabolic. I mean, for UDL throughout, it will be 0. Okay, it will be 0. Horizontal reaction will also be same. That is WL square by 8. WL square by 8. Okay, that's the end of it. That's the end of it. We have discussed almost all the important concepts of structural analysis. And if you feel like you have any doubts or something like that, you can put that in the comment section. I'll be having a look at it all the time so that we can interact with each other. Don't feel bad or don't hesitate to ask your doubts in the comment section. I'll be clearing your doubts. Don't worry about that. So shall we end the session for now? Shall we finish the session? Yeah. Prepare well, stay safe, stay healthy. Only 1 month is remaining for the exam. You have to prepare as much as you can, try to score as much as you can. Revise all the things, don't forget to revise. Do your best. Okay. All the best for your examinations. So bye.